Welcome to lesson 18. The last lesson looked at how to add some significant numbers. This time we'll look at the process of subtraction, again using numbers which are quite large. In this era of calculators, very few people manually do subtraction. One can simply tap a few digits and then see the answer. There's nothing wrong with this. The calculator is an excellent labour-saving device. Unfortunately, though, this removes the concepts of size and processing, and that can be a hindrance for a maths student who is in learning mode. There are many ways of setting out a formal process for subtracting two numbers. The method we are demonstrating here might not be the one you are familiar with. If that's the case, examine it closely to see that it's still based on the same principles as the one you use. All approaches can be summarised by saying, if a number is not convenient, then change its appearance. In this technique, we restrict any changes to the larger number. I'll switch you through to Miss Georgina's class. She is our subtraction specialist. You'll notice that she's being assisted by Felix, but to be honest, I don't think he's interested in mathematics.
When calculating the answer to a subtraction problem, the top number must be larger than the second one. In each step of the solution, the top digit must be larger than the one under it. If it isn't, we must adjust it before proceeding with our solution. The top digit must be larger than 4, so we restructure the 3. This becomes 13 by removing some of the value from the 2, in the tens column on the top line. The first subtraction step is 13 minus 4. This gives 9. Here we restructure the top number so the top digit will be larger than the lower one. The subtraction step for this column is 11 minus 7. So we write 4 in the answer. 5 is larger than 1, so we shift 10 across to the 1. 11 take away 5 leads to 6. Our final step is 3 minus 0. So this answer begins with 3.
This method of calculation changed the appearance of the top number by rearranging how its value is expressed. The original number, 4,223, had to be modified because some of these digits were smaller than the number below it in the calculation. So the 4,000s can be re-expressed as 3,000 and 1100s. Notice 3,000 and 1100s still conveys the value of 4,000. Do you see that they are equivalent? Here's another way of expressing them. 3,000, 1,100, 11 tens, and 13 units. Normally, we only have one digit in a column, where the column indicates size. So if we tidy that up, we get 4,223, which is actually the number in our calculation.
The first subtraction step is 8 minus 8. This gives 0. Here we restructure the top number so the top digit will be larger than the lower one. The subtraction step for this column is 14 minus 5. So we write 9 in the answer. 2 take away 2 leads to 0. Our final step is 5 minus 1. So this answer begins with 4.
Now, another popular approach to subtraction is based on increasing both numbers in the calculation in a way that leaves the top digit larger for each column. Now, here's the original calculation. Notice the top digit is not larger, is not larger, is not larger. So we're going to increase the way this number is expressed and the way this number is expressed so that in every case the top digit is larger than the lower one. And here's how we do it. Where we have a number that we want to make larger, we add 10 of whatever that column is worth. So here this represents adding 10 hundreds. And 10 hundreds is 1,000, so we add 1,000 to the thousands column of the other number. So we've added the same amount on each level. 10 hundreds on the top and 1,000 on the bottom. So the two numbers we have will be equivalent, but the way they're expressed will be different. So here's the calculation after we have adjusted the values. We have 4,223, but we have added 10 hundreds, 10 tens, and 10 units. So now our calculation becomes simply 4 minus 1 for the thousands column, 12 minus 6 for the hundreds column, 12 minus 8 for the tens column, and 13 minus 4 for the units column. So now we can do the calculation because each digit on the top line is expressed in a way which makes it larger than the appropriate digit in the bottom line. Another approach to subtraction processes matching digits and then fixes the answer to make it presentable. So if we have a look at an example of how this is done, there's the same calculation we had before. We simply subtract the digits in each column. But if we start with 3 and remove 4, we have a deficit of 1. We call it negative 1. If we start with 2 and remove 7, the deficit is 5. So we have negative 5. 2, take away 5, negative 3. 4 stays 4. Now this answer is correct, but most people don't understand it because of the presence of the negative parts. So what we have to do is tidy it up, make it more conventional. So we begin by looking at 4,000 minus 300. Well, that's 3,700. Now we look at the next change. 700 minus 50. Well, that's 650. And finally, we look at 50 minus 1. That's 49. So our answer that was expressed in a non-conventional form has been rearranged to form the conventional appearance. So our answer that was expressed in a way that was not conventional has been rewritten in the conventional format so everybody can understand it. Each line in the tidying up process here is a correct answer. They are simply getting closer to what is the conventional form. It looks cumbersome, doesn't it? Well, actually it isn't. It allows you to do the subtraction from either end, and that could be an advantage in some circumstances. It certainly is different, but that doesn't mean it is of no use ever. So there we have three different approaches to the same task, subtracting two numbers. In the first, we change one number, the top number, so it's always larger than the lower digit. In the second, we change both numbers by the same amount, but making their appearance quite different. And in the third, we just went ahead with the subtraction process and then adjusted the answer. Although the processing looks very different, they all finish up with exactly the same correct answer. If you're comfortable with all three, you're ahead of most people. Is any one method better than the others? Often not. You just use the method you are familiar with. But if you want to be the best at mathematics, you have to understand that many of our techniques are simply one of numerous approaches. So what does all this mean? Don't be put off simply because something looks different. Although you don't recognize it, it might be a modification of something you already understand. Break a new task into small pieces and think about what's really happening at each step. So in conclusion, whenever you meet something new, investigate it carefully because it might be something old presented differently. I'll send you back to Miss Georgina for a final look at subtraction. I hope to see you in the next lesson.
The top digit must be larger than 1, so we restructure the 0. This becomes 10 by removing some of the value from the 0, in the tens column on the top line. The first subtraction step is 10 minus 1. This gives 9. Here we restructure the top number so the top digit will be larger than the lower one. The subtraction step for this column is 9 minus 3. So we write 6 in the answer. 1 is larger than minus 1, so we shift 10 across to the minus 1. 9 take away 1 leads to 8. Our final step is 6 minus 5. So this answer begins with 1. Your answer is correct. Well done.